highlighted on the picture or not. I think it helps to see again the kind of the definition of mutually exclusive or not and how it relates. Those are the spades. Here's the red cards. This is what I mentioned before, right? Those are mutually exclusive because they do not overlap at all. If you know that you got a red card, you know it can't be a spade, and vice versa. Those are the two that are mutually exclusive because the other ones, the face cards here, are right here, right? These are all the face cards. That overlaps with both the other ones. This is not mutually exclusive to either of the other ones. Okay, which of these events are S and R? No overlap, right? Or in other words, the other way of saying that is probability of S and R happening together is 0. If you figured all the probabilities there, well, we just said S and R is 0. Chance of getting a spade is 13 out of 52. You could reduce that if you want. Chance of getting a red card is 26 out of 52. Chance of getting both a red card and a spade at the same time. Again, this is one card. Don't get mixed up and start to think this has to be choosing two cards. You may have done stuff like that in grade 8 and 9 when you thought of this, well, when it was choosing two cards. Those two events can still deal with one card, right? You can say one event is the card's a spade, one event is the card is red. It doesn't be, just because there's two things inside the brackets here does not mean that you're choosing suddenly two cards. Those relate to the same card. And then the last one here, S or R, if you counted them all up, well, if you have 26 and 13 and they don't overlap, you have 39 out of 52. The connection here you're making is how that ties into the addition law, right? If you use the addition law and say, if I want to determine the probability of S or R, I can take probability of S plus probability of R minus probability of S and R. And in this case, since they're mutually exclusive, that's 0. This is 13, 52. This is 26 out of 52. The minus 0, right? And you get that number that that relates up here, this number, right? 39 out of 52. The other ones there that overlap with each other, S and spade and a face card. So maybe we'll take out the red ones for a second. Spade and a face card, there's an overlap between them there, right? There's the overlap. And it's important to see how that comes out from the formula, right? Probability of a spade is, again, 13 out of 52. Probability of face card is 12 out of 52. Notice that that doesn't mean that this is 25. It's not 25, right? Because there's an overlap. You've counted those three that are in green twice. There's 3 that overlap. So there's really only 22 here if you add them up. There's 13 that are blue and there's an extra 9. That makes that many, right? If you work it out on the, using your formula here, chance of S or R, chance of S plus chance of R, F, face card, minus chance of both of them, spade and a face card. If you can see that the overlap is 3, which it is, 3 out of 52 here. I have to get rid of the picture for a second. 3 out of 52, and you know that this one is 13, and this one's 12. You can work it out indirectly as long as you know what that is, right? Add them and subtract the overlap to get your 22 out of 52. All right. The other two questions are here. I'm not sure if you tried them or not. Both, again, involving situations that involve overlap. Two different things that involve some overlap here. This, you can tell, is kind of dated by the language as well as the numbers involved. I don't know if anybody says surf the internet anymore, but nonetheless, it's in the question there. And I think if you look at the numbers, they're a little bit off, right? Class of 30 students. So there's 30 students in total. 16 of them surf the internet. Pretty sure that's higher now. And 10 students use email. If it's only 10 students using email now, it's because they've gone past that and they're using other means of communication electronically, not because they haven't figured it out yet, which is probably how old this question is. Anyways, if you want, you can kind of solve these things two ways. If you're a visual person, maybe using the Venn diagram is helpful. If you want to use that formula, you can use that formula, right? As long as if you're going to use a formula, as long as you define some symbols, it makes it easier. If you're going to use, I don't know, I is student uses internet. And E can be student uses email. If you're using I and E. You're asked what's the chance that somebody you pick at random surfs the internet or uses email. Of course, mathematically that means or both, right? One or the other, or both. If you want to use the formula, you want chance of I or E. The numbers you're given in the question are all the other things you need. You want chance of I, chance of E, minus the overlap, I and E. Okay? So this is one, other, or both. This says 16 out of 30. This is 10 out of 30. So it's not 26. You have to subtract the overlap here of that. 20 out of 30. Right? Because there's those 6 that do both. If you're more of a visual person, you can make a Venn diagram, right? And Venn diagrams don't have to be circles, by the way. They can be whatever shape you want, rectangles, ellipses, anything. Okay, if we're making this Venn diagram here, and then maybe make a rectangle around the outside to show the rest of everything there. So think about the numbers that we have here. If this is going to be I and this is going to be E, for a Venn diagram, you approach it differently, but you probably start with the middle if you know that. We know that there's, how many are in this spot right here? That's the and, right? So it's how many? 6? You can either put 6 or you can put 6 out of 30 if you want. You can just understand that all of them are out of 30. You can put percentages in a Venn diagram, you can put numbers, or you can put probabilities. Maybe we'll just understand that the whole thing's out of 30, so we'll just put 6. And then you need to realize, though, that if you're doing this, if 16 use the internet, this whole thing is 16 using the internet, right? That whole thing is 16. So then, how many go in this spot right here? What has to go in that space? 10, right? There's 10 who use the internet but not email. And then the same thing with this one, right? If you're using, if you're making this blue here, you know that there's those 6 in the middle, so you got to think about how many put there. My picture's not proportionally correct, but that's okay. If that's 10, this has to be a 4. If you add all those up, you get 20. There's 10 out here. Not that you need that in this, to answer this question, but same thing here, 20 out of 30. You're just visually doing the same thing, working backwards like that. All right. Can you try thinking about the last question here? Maybe do it both ways. Set up a Venn diagram and use formulas if you want. I would set up the thing first and make a list of what you have. Use A for first project, B for second project, or something like that. Make a list of the probabilities you're given here, and then see what else you can work out. Okay?